Alright students, here's the solution for the practice SAC that you just completed. Hopefully, obviously complete the practice SAC before you do this. Alright, so question 1, actually the first, I believe 8 questions are multiple choice based on what the practice SAC says at the start. So let's do it. In the sequence 21, 18, 15, 12, the next term is, so let's identify if it's going up and down. Obviously it's going down, but by how much? Okay, and we're looking for the next number. It's going down by 3, minus 3, and I can do that based on trying to find the common difference, which is, remember, any term minus the previous. So let's say I use this term, take away the previous term, which is 21, and that gives me minus 3. So hence why I have minus 3 as my common ratio difference. That means the next number after 12, take away 3, is equal to 9. So 9. Next one, the sequence that represents a common ratio difference of 4. Okay, common difference, not common ratio. Common difference meaning you're adding by positive 4. So adding 4. Okay, that's what that common difference is saying. So let's look for the one that is adding 4 in each sequence or each term. So 4 plus 4 is 8, which is correct. 8 plus 4 should be 12, so it's not 16, so this can't be that. 3 plus 4 is 7, good. 7 plus 11 is 7 plus 4 is 11, good. 11 plus 15 is 4, so 11 plus 4, sorry, is 15, so it should be this one. It can't be this because it's going down by 4. 14 minus 4 is 10, so that won't make sense. It can't be this either. 1 to 4 is 3, 4 to 16 is 12, and then so on and so forth, and this goes up by 2, so neither of those. It's just B. Question 3, in this sequence, 500, 400, 200, 300, 200, 100, the fourth term is, so what's the fourth number? So remember T1, T2, T3, T4 right there, 200. Okay, easy. Using the recurrence relation below, the fifth term in the sequence is, what's the fifth number? Well, let's list out the numbers. So T1 is 5. T2 would be, look at the recurrence relation. It's saying that to get the next number, you're adding 12. So that means T2 is going to be 5 plus 12, which equals 17. Okay, we're looking for the fifth number. T3 would be 17 plus 12, which gives us 29. T4 would be 29 plus 12, which gives us a value of 41. And that means T5 would be 41 plus 12, which equals 53. Okay. Next one, the next term in a geometric sequence with a common ratio of 2 can be found by, okay. So what this saying is, you've got a geometric sequence and it's a ratio of 2. So what are you doing? If it's a common ratio, that means you're multiplying. Okay, in this case, it's multiplying by a certain amount. Also, it could be dividing. Okay, but here it's in this case, you're multiplying with 2. Okay, so that means it's going to increase. It's not really dividing in this case. So adding by 2 is not going to work. Subtracting won't work. Multiplying most likely is going to be the case. Can't be this. I will say technically it could also be dividing by the previous term by 2, but okay, in our scenario we've mainly just been working with multiplying with numbers. Okay, so generally as well, if it's a common ratio of a solid number like 2, it's implying that it's going to increase. If it's dividing, it's going to decrease. It's got to be less than 2, but it's all good. All right, next one, recurrence relation for the sequence 9, 27, 81. Okay, would be Again, looking at trying to figure out first of all what's the first term. T1 is right there. Okay, which is 9, and then looking at the common ratio. Remember, for the common ratio, it's any term divided by the previous, so I can go 81 divided by 27, which gives me a ratio of 3. So my recurrent relation should be T1 equals 9, and then Tn plus 1, I'll write that again, is equal to Tn, again, common recurrence relation to sec, it's a common ratio type question, yeah? And I recognize that because it's not going up by the same amount, it's multiplying, okay, by the same amount. And the ratio in this case is 3. So looking at these 3, okay, these 5 answers, I can see that it could be this, but looking again at the common ratio there, it's 9. Okay, now this actually is the same as Tn times 9. Okay, so don't get scared if it looks like that, but that's obviously not the answer. Can't be this plus 9, so it won't work. It's actually this one. Okay, because remember this is the same as Tn times 3. And that's what we have before this part of the recurrence relation. And the first term is 9. Okay, so it's pretty straightforward. Won't be that, because it's not adding, it's multiplying by the same amount. A 7% increase is made by using the common ratio of, so 7% increase. Remember, we have 2 options, okay? We either have the decreased common ratio, 1 minus percentage over 100, or we have the increasing common ratio, 1 plus percentage over 100. In this case, because it's increase, we're going to use this one. Okay, so that means it's going to be R equals 1 plus 7 over 100, which gives you a common ratio of 1.07. So this one here. Don't write down 7% or anything else. Okay, use this common ratio formula. And also, hopefully this doesn't confuse you guys, but remember, this is slightly different to when there's multiple compounding periods. Alright, so you will come across that surely in the next few questions. A 12% decrease. Now this is a decrease, okay? So if it's a decrease, you're going to be using R equals 1 minus percentage over 100. Okay, remember the other one that we had, which I used just previously in the other question, R equals 1 plus percentage over 100. So that's if it's increasing, but here it's decreasing, 12% decrease. So we're using this one. So it's going to be R equals 1 take away 12 over 100, which means that it's 0.88. Okay, so the common ratio, 0.88. All right, let's do the short answer questions. Guido's phone plan gives him a data allowance of 50 gigabytes each month. He records his daily usage and finds that the amount of data he has left over decreases at a rate of 8% per day. Determine the common ratio that represents Guido's data usage. So let's read the question. Okay, you can see that he records his daily usage and he has left over, and it decreases at a rate of 8% per day. So decreasing at a rate of 8% per day. So that means if it's a percentage like this and it's decreasing, we're going to use our R equals 1 take away percentage over 100. It's asking us for the common ratio. So we use, if it's a percentage involved and it's decreasing, remember that's when we use this. So in this case, R equals 1 take away, the percentage was 8. So 8 over 100, which will give us, is our answer, 0.92. So that's my common ratio, 0.92. Next question, generate the amount of data for each of the first 4 days of the month. All right, so each of the first 4 days of the month. So for, remember, this sort of question, that 50 in this scenario would not be the first term. It's a starting term, okay? So just keep that in mind. So that means if the starting term is 50, and how do I know that? Well, read the question. It doesn't say that 50 gigabytes was the start, or that was the first day. Okay, and the question is saying how much does he have left over at the, he's measuring how much he has left over at the end of each, or has left over basically. So after day one, obviously you'll be using some of your data. Okay, so at day one or T1, remember to get the next term you're multiplying by 0.92. So it's going to be 50 times 0.92. You don't have to show you working out for this because it can get a bit much. Okay, right, we'll just list it. So I'll show you how to do it on a calculator. So you start off with 50. Okay, press enter, and then you're multiplying it by the common ratio, 0.92. So day one is 46. Day two, 42.32. Day three, got 38.93. And then day four is 35.82. Alright, so all I want you to do, at least for a question like this, is just do these as your answer. Okay, you don't have to show you working out. How much data will we have left over after the 20th day? Okay, so on the 20th day, how much does he have left over? Let's calculate that. Well, we got up to day 4 here. So we'll go 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. On the 20th day, he'll have 9.43 gigabytes left. Alright, next question. 12,500 is invested for 7 years at a simple interest rate of 15% per annum. Determine the amount of interest earned per year, the common difference D. Alright, so for these sort of questions, okay, it's a simple interest question. It's related to arithmetic. Okay, so that means for this one, we need to find 15% of that amount. Okay, so 15% of 12,500. So let's work that out. That'll be, remember, percentage over 100 times T0. This is T0, meaning the starting amount. So in this case, it's going to be 15 over 100 times T0, which is 12,500. Okay, and that would give us so 15 over 100 times 12,500. So that means per year we're making 1875 in interest. Okay. Next question, what is the total value of the investment? So we're trying to figure out what's the value after the 7 years. So work that out on your calculator. Okay, so let's start off by typing down the starting amount, 12,500. And you know that based on that, you're adding, so plus 1,875 per year. So we have to figure out the value after 7 years. So if I press enter, it's first year, second year, third, fourth, fifth, sixth, seventh. So there's my 7th year. So T7 is equal to 2,565. So that's how much money he'll have after the 7 years. What would the value of the investment be if this changed to a compound interest investment paid annually? Okay, so this one's slightly different. We're going to, instead of using adding by the same amount, we're going to have to figure out how much it would be if it was a compound interest. So hopefully this doesn't trick anybody or it doesn't trip you up, but remember it's 12,500 for 7 years, so that doesn't change. 12,500, 7 years, but instead of simple interest, it's going to be compound interest. So it's still going to be 15% per year. So it's adding 15% per year. So in this case, we need to figure out the common ratio first. So start off with the ratio. It's increasing. Yes, it's going to be 1 plus 15% over 100. That means my common ratio is 1.15. So multiplying by 1.15. Remember, if it's compound interest, you're multiplying. So in this case, we have to figure out the investment after 7 years. Right? So remember, you're starting off with 12,500. Okay, but instead of adding 1875, we're going to multiply it by 1.15 because it's compound interest. So don't forget, press enter, then times 1.15. Right? And we're looking at it for 7 years. The amount doesn't change. It's still 7 years. So the number of years doesn't change. So let's go year 1, 2, 3, 4, 5, 6, 7. So on the 7th year, okay, the amount will go up to 33250.25. Oops, 250.25, which is a lot more than what he would have gotten if he went with simple interest. As you can see, simple interest, compound interest. All right, last question. 10,000 is invested at a rate of 7.7% compounded monthly. All right, some key information there already. There's my T0, there's my rate, and it's compounding monthly. Okay, so it's going to be compounding more than once per year. And if you remember back to what I said earlier when we were doing these solutions, you're going to come across a question, okay, where you're going to be compounding more than once. So these are just compounding once a year, these common ratios. But now we're going to do a question where you're compounding more than once a year. And remember the change in the formula. What happens here compared to obviously what we have now? There's something that changes. So let's go through it. State the principal amount and the percentage change. So first of all, let's state the principal, T0. The principal right there, 10,000, easy. Okay, let's fix my zeros a bit. Okay, and then what's the percentage change R, common ratio? Now, for this one, okay, because it's compounding more than once per year, remember the original we had was 1 plus percentage over 100. And this is if you're compounding once per year. So all compounding annually. Okay, that's what this one was. But if you're compounding more than once per year, okay, I'll write that here actually. Let's do this first. The formula is going to be 1 plus the percentage divided by the number of compounds over 100. This is multiple compounds per year. Okay, so just keep that in mind. If you're compounding only once per year, we use the formula in blue. But if you have multiple compounds per year, so when you see the word monthly, weekly, daily, that's when you use this. Okay. All right, so firstly, let's understand, what does monthly mean? Monthly, okay, means that it's once a month. Well, yeah, once a month. But basically every month of the year. So it's going to be 12 times per year. That's going to be my N. Okay, number of compounds per year is 12. So now we're going to use the formula, because it's multiple compounds per year, to figure out what the common ratio is. So in this case, it's going to be 1 plus the percentage divided by the number of compounds over 100, which gives us 1 plus, the percentage was 7.7, as you can see, divided by number of compounds per year, which is 12, that divided by 100. So this will give us our common ratio R. And so 1 plus 7.7 divided by the number of compounds, which is 12, over 100, which equals 1.0064. That's my common ratio right there. Now, if you were to put your answers here, I wouldn't mind if you just put this, or at least R equals this, okay, as your answer. Okay, write a recurrence relation for this investment. So let's make a recurrence relation. Remember, your recurrence relation should look like this. T0 equals the starting amount. Also known as the principal. Okay, and then Tn plus 1 is equal to Tn times the common ratio, or the percentage change R. Alright, so in this case, let's work it out. T0, that's pretty easy. Starting amount, or the principal, is equal to $10,000, because that's how much you started with, yeah? Reading the question. Okay, and then Tn plus 1, so I'm just going to underline that so you know. That's where you got to change. Tn times the common ratio of 1.0064. There's my recurrence relation. Alright, next question is state the value of the investment after 3 years. Calculate the 2 decimal places. Now, again, some of you guys made the mistake of doing this in the CFAT, where you thought 3 years was the third term. Okay, but remember, you're compounding 12 times a year. Okay, it's compounding 12 times a year, meaning it's being paid 12 times per year, and it's over 3 years. So if it's compounding 12 times per year, over 3 years, what term is that going to be? Well, you're going to be going 3 times 12. Okay, because it's 12 times per year, which means you're looking for the 36th term, T36. Okay, T36. Now, you can, if you really wanted to, use your calculator for this and work it out recursively. So you'd go 10,000, enter, and then times the common ratio of 1.0064. And you can press enter 36 times. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. I think I kind of already lost count. Okay, which is a bit much. It gets a bit much. So the quick way, okay, that I showed you guys yesterday, if you watched the video or if you were present, remember, was you could use this rule to find large high value terms. So you could go Tn is equal to T0 times R to the power of n. Okay, and what this is saying, or what this is, okay, n refers to the term number. So number. T0, remember in this case, is the starting or principal. R is the common ratio change, or the thing you're multiplying by. And then N is the term that you're looking for. Actually, I should make this term you are after, and then this is term number. Okay, so Tn and N are more or less the same. Okay, but you would write this formula in this way now. So you'd go, oops, you'd go Tn or T. Sorry, we're looking for the 36th number, so T36 is equal to, looking at the, if you've forgotten what each of the formula looks like and what each of these mean, T0 is the starting amount or the principal, so in this case, the principal is 10,000, right, reading the question, 10,000 times the common ratio of R, which is 1.0064. Okay, and I got that from my R value there, see? And then to the power of the term we're looking for is 36, so the power of 36. So that means T36. Put it in your calculator. 10,000 times 1.0064 to the power of 36. So that means the answer is 12,581.7, or we'll round it to 0.8. 0.80. Okay, 12,581.80. I could test it on my calculator as well. Again, you could do it the long way, but remember, it just takes a while. 1.0064. And you can press enter 36 times here. So I'll try not to lose count this time. 1, 2, 3, 4, 5, 6, 7, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 27, 29, 30. 1, 32, 33, 34, 35, 36. And there's your answer as well. Okay, but again, it's a bit trickier. So I would suggest that you use this formula, okay, to figure out high value terms, because it's just a lot easier. There will definitely be a question where you might be asked to find the 70th term or the 100th term. So you use this formula, okay? And that's it for the solutions. Thank you.